Hi guys, today we're going to do 10.6, building a house. It's a longer section, so we're going to get moving on this. You have now decided that you are going to build a house, and you have a lot of decisions to make. And most of your decisions, truthfully, comes down to the cost. How much money do you have to spend? And you have a budget. Remember, we've been talking about a budget. So you've got to make sure all your costs can fit into that budget. Two things that you're looking for when we're building a house is first, your building site. We call that a lot. You're going to have to find a place that you want to build that best meets your needs. Second is the house plan. What do you want your house to look like? Will it be a single story? Will it be a ranch house? Will it be a two-story, tri-level? You're going to decide the plan that best fits you, and you are going to get a detailed set. That detailed set is what your contractor will use to build your house. Your detailed plans will be drawn to a scale. An actual house, you can't draw it full scale because it won't fit on a piece of paper. So we have to use a ratio that is constant through all our measurements for the whole entire house so that it will be uniform. The most common scale that is used for blueprints is 1/4 of an inch equals 1 foot in the real house. So we're going to keep moving on here, and we're going to do some examples here. How do we use this scale? Well, we're going to have to use dimensional analysis. That thing is coming back to haunt you guys. So let's remember how we do this. We got an example here that deals with a driveway. In our blueprint, it measures that this driveway is 3.5 inches wide. And so what is that really in real life? Well, we're going to use the common scale, which is 1/4 of an inch equals 1 foot, to figure out what this is. So remember, when we do dimensional analysis, we always use our first measurement here. And we're going to go ahead, and since it is a mixed number, we have to turn it to an improper fraction. And to do an improper fraction, we take the denominator, we times it by our whole number, so 3 times 4 is 12. Add the numerator, which is 3, and that's how we get 15 for the numerator. And then we use the denominator of our fraction, 4. So we're going to go ahead and put that into the dimensional analysis. And remember, that goes in the numerator, so we'll stick a 1 underneath it. Dimensional analysis uses the multiplication of another ratio that equals 1, and that ratio is 1/4 inch equals a foot. Now I know the 1/4 of an inch has to go in the denominator because remember, I need my units to cancel each other out. I can't have that fraction in the denominator, so I'm going to eliminate it by multiplying by the reciprocal. When I do that, it cancels out my denominator, and I'm going to be left with 1. So here it is rewritten, so it looks a whole lot nicer. Here is my 15/4 times my 4/1, which is in the numerator. Remember, what I do to the bottom, I have to do to the top. That's how I got the 4/1. Now multiply. To make it easier, I'm going to cancel out as much as I can to reduce my fraction before I even multiply. So these 4 are on a diagonal. Remember, I can cancel out on a diagonal, so those turn into a 1. Okay, now I just multiply us straight across for my fraction. 15 times 1 is 15. 1 times 1 is 1. So my measurement, the real size of my driveway is going to be 15 feet wide. Okay, so now let's use this information to help us with a building of a room size. And so here we have our example that Mr. Johnson's living room is going to be 13 feet by 18 feet. And we want to know what the size is going to be in our scale drawing. So we're going to do exactly like we did up here at the top. We're going to do a dimensional analysis, and we're going to use the same scale, the 1/4 of an inch to a foot. So because I have two measurements here, I have to treat them separately. So I need to first convert my 13 feet using my scale. I know my foot has to go in the denominator because I want them to cancel out. My 1/4 inch goes up here. Now in this case, I don't have a fraction in the bottom. So I'm going to go ahead and just straight multiply. Here's my 13/1 times my numerator of 1/4. I'm not worrying about the denominator because it's 1. So I'm just going to straight multiply. 13 times 1 is 13. 1 times 4 is 4. Now I'm going to turn this back to a mixed number. We tend to, when we're building, using mixed numbers, not in proper fractions. So I'm going to take 13, divide it by 4 to get my whole number. What's left over is really the fraction 2, actually, sorry, for this one is truly 1/4. So it's 3 1/4 of an inch. Now we're going to go ahead and do the same for the denominator. And do the same thing. Here's my 18 feet from up here in the example. Same scale. I knew foot had to be in the bottom so they would cancel each other out. Now straight multiply across. And 18 times 1 is 18. 1 times 4 is 4. 4 can go into 18 4 times. This is where we have 2 left over because 4 times 4 is 16. 18 minus 16 is 2. So my fraction is really 2/4. But I'm going to reduce that down to 1/2. That's how I get 4 1/2. So this is the correct way to write my answer. We tend to use this for measurements of rooms. And so it's 3 1/4 inch by 4 1/2 inch in our scale drawing. Okay, let's do another example here. We've got a lot of examples to show how we use this in the building situation. Here we are going to have a contractor and we want to side one of our walls of our house here. And so we need to find out how much do I actually need so that I know when I go to Menards or Lowe's to tell them how many boxes of the stuff that I need. So let's go ahead and look at our example. The one wall that I'm looking at is 10 5/8 of an inch by 2 1/2 inch. This obviously is our scale drawing, not real life. So we're going to need to know what scale we're going to use, and we're going to check out our example, and it says in it we are going to use 1/4 inch per foot. So it's our traditional scale that we've been using. So what did I do last time? Well, I need to go ahead first and get it from my scale drawing to real life drawing. So once again, I got to convert. So I'm going to, because it's double measurements, I need to first convert the one side. So change this to a mixed number, use my scale. I know this was inch, so inch had to go in the bottom to cancel each other out. In this example, I've got my fraction in the bottom again, so I have to multiply by the reciprocal to cancel that out. What I do to the bottom, I do to the top. So now in my bottom I have 1, so I'm just going to multiply the numerators. So 85/8 times 4/1. This can cancel out to make it a lot easier. 4 goes into 8 2 times. Now I can multiply straight across and I get 85/2. Go ahead and you can divide that out and get 42.5 feet, or you could write it as 42 1/2 feet. Either measurement is fine. Now I need to do the same with my 2 1/2 inch. You notice, go ahead, same method, get rid of the fraction, multiply it out, and I end up with 10 feet. Okay, so now that I've converted these measurements, what do I do? These are real life size measurements, and so now I need to go ahead and find the area of this wall. So I am going to go ahead and I am going to multiply. Remember, area of a rectangle is area equals base times height. So I'm going to take these measurements, insert them into my equation, multiply them out, and I find out that I have 425 square feet of area that I need to cover with this. And so I know that's what I need to go ahead and look at. Well, our contractor has bought siding before, and he knows that 1 square of vinyl siding, and that's what they call a box, is a square. Basically, a square of vinyl siding covers 100 feet square feet. And so, knowing that, how many boxes do you think we're going to need to buy for that one wall of the house? Well, if each of them are 100, 4 of them would give us 400, and that would not be enough. So I need to go ahead and buy 5 boxes. I'll have stuff left over, but I need to make sure I have enough to cover that 25 square feet. So 5 boxes will have to be. Okay, let's talk about land now. Okay, so we now have decided we need to buy some land. We know what type of house we want, and so when we buy land, you have a couple options. You can buy by acres, or you can buy by a lot size. Lots are normally measured by feet and inches, and acres is a large portion of it. So we're going to use some scales that the book gives us. And so these are the measurements that are prearranged that we know. We know that 1 square mile really equals 640 acres. And 1 acre is 43,560 square feet. And 1 acre is 0.4 hectares, which is definitely larger than an acre here. Okay, so these are our basic measurements that we're going to use. Be careful when you read different problems. They might give you an extra measurement in that we're going to use. So let's look at an example here, okay? So we have a rectangular lot that we're looking at. It's 155 meters by 210 meters, okay? We want to know how big is this in hectares. So what we need to actually do when we look at this is we have to find the area for it. So we're going to simply take our two measurements here, basically length times width, and multiply them out. And we find out that we have 32,550 meters squared. Okay, now we are given here in our problem that 1 hectare equals 10,000 meters squared. If you notice, this is what we tend to use in standard measurement. Here we're dealing with meters, so they had to give us an extra conversion here for our problem. So we're going to go ahead and with our normal dimensional analysis here, we're going to put our number in the numerator. Technically this is all over 1 here. Okay, and now we're going to multiply by our conversion factor. And our conversion factors is what they gave us here. Now I know I need to put the 10,000 meters squared in the bottom so that my meters here can cancel each other out. Now I'm just going to go ahead and multiply. When I multiply this, I end up with 32,550. 1 times 10,000 is 10,000. Go ahead and divide them out, and I find out that 3.255 hectares is what this lot is. Okay, so that's how we can do that. Let's do another measurement here, a little bit different. We have a family here called the Franklins, and they're looking at 2 lots. And this is a lot of predicaments that homeowners find. They find 2 areas that they like, and they want to decide which one to buy. Here in this case, we want to see which one has the biggest acreage of it. We want more land. Okay, we have a lot here that is 192 by 145. It's pretty square here. And then this one is a long rectangle. It's 100 by 300. So they want to know which one is actually the larger area. So to do this, what we're going to do is actually take and find the area of the measurements. Okay, we're already in feet, and so I know that there's a nice conversion with acres and feet that they gave us from the book, and that was up here in our total. We knew 1 acre equals 43,560. So I don't need to do any converting for that. I can just simply go straight to the area. Once I get my area for them, then I'm going to do the converting to change it from squared feet to acres. So I'm going to use that conversion factor, and I'm going to put the 43,560 feet squared in the bottom so that my feet can cancel each other out. The 1 acre goes in top, multiply them together, and I end up with that. Same thing over here. I'm going to do the conversion factor. My feet squared cancel each other out, multiply it, and then I divide. And I find out that this one here, the more squared one, is 0.64 acres, and this one is 0.69 acres. So not much of a difference, basically 5/100ths of a measurement here, but this one is a little bit bigger. So just by going size, this second lot, the long rectangle one, is what they would be looking at purchasing. Okay, so we talked about how to find the area for converting by scales, how to find area for buying siding, and now we're going to actually look at dealing with buying materials for the roof. Now the roof is a little bit different because it's on an angle, okay? And that angle is called a pitch. And that pitch affects the amount of roofing materials that we will need. And so if you look on page 392 in your textbook, you have table 10.3. Now this table gives you the ratio, or the factor it's called, for what we need to multiply our goods by to take in account the pitch of the roof. So how does this work? We're going to use an example here. And our example is Mr. O'Connor. He's an estimator for a contractor, and he's looking at a scale drawing that's 1/4 of an inch to 1 foot, and he measures the pitch of the roof to be 8 to 12 on the gable roof, and this is what the scale model is telling me the roof dimensions are. And then it goes on to say, if the ridge runs with the long dimension, how many squares of roofing material is needed for the roof? Now this ridge running with the long dimension is what we're going to pay attention to when I need to multiply by the factor. So let's go ahead and get into this problem. So the very first thing I need to do is, this is my scale. I need to go ahead and figure out how much in real life material do I need. So I need to convert my scale to the real measurement, which is foot. So once again, like we did before, I need to take this measurement and convert it to foot, and then take this measurement and convert it by foot. So here's my measurement, turn it to an improper fraction. Here's my scale. I knew the 1/4 had to go in the denominator, so the inches would cancel out. Then I need to multiply by the reciprocal, so my fraction cancels out. What I do to one, I have to do the other, so I have to multiply the numerator by 4/1. This cancels out to 1, so now I multiply this. And I can reduce. 4 goes into 8 2 times, so it makes my fraction easier. And so I end up with 117/2. Divide that out, and I get 58.5 feet. Then I'm going to go ahead and do the same for the length now. If you notice, it goes width times the length. So I knew my second measurement here had to deal with the length. Convert it just like I did up here. And once you do the math, you find that you get 79.5 feet. Now that I have that, I'm going to go ahead, and the next step is we're going to go ahead and we need to adjust the width. This is because, remember, we have the pitch here, and it tells me the ridge runs along the long dimension. So that means the pitch is going to affect my width. And so I'm going to take my measurement that I got for the width here, 58.5, and I'm going to multiply it by the factor that I find in the chart. And the chart again is on page 392 of your book. And I'm going to look on my chart to see where I have the pitch being 8 to 12. So if I look in the chart at 8 to 12, I see the factor is 1.2019. So all I'm going to do is take that factor, multiply it by my width, and I get this. This is the width that I'm taking in account to because of the pitch. Now, the step 4 that I need to do is find the area. I'm going to use my new total for width here and multiply it by my length. And this is my area. Okay, so this is how much area that I have to deal with buying supplies. Now, it told me in this problem here that 1 square is really 100 square feet. So I'm going to take my area here, and I'm going to simply end up multiplying it by my ratio, which means I'm going to take that area, dividing it by 100. And that's going to tell me how many squares I need to buy. So I find out after doing the division that I end up with 56 squares. Okay, so this is all the examples and all the information this section deals with. Now let's take a look at your real homework assignment here. These assignment problems match up exactly like the examples we just did, but let's give you an idea, since we're not in class, to see how we work with it. So problem 1 in your book says convert the scale drawing measurements into feet. And so problem number 1 says that my measurement is 3 3/8 of an inch, and the scale is 1/4 to 1 foot. So I need to set up and do dimensional analysis. I know my inch has to go in the bottom so that they cancel out. Remember, I need to get rid of the fraction, so I have to multiply by the reciprocal. So this now cancels out. And what I do to the bottom, I do the top. So now I'm going to multiply. If you notice here, I did the conversion. I had to do 3 times 8 to get 24, plus 3 is 27 over 8. So there's my improper fraction. Reduce my fraction here so I can multiply a little bit easier, and I end up with 27 over 2. 27 over 2 ends up being 13 and 1/2, and I'm in feet now. Okay, so 1 through 4 are going to be exactly like that. Now we're going to go ahead and we'll look at number 5. Number 5 is a new section here, and basically number 5 says convert the dimensions into scale drawing dimensions for the given scale. So they give me the dimensions of 5 foot by 9 foot, and my scale is once again 1/4 to 1 foot. So remember how we did it in our assignment, in our examples, I had to take one measurement and convert it, and then I had to do the conversion for the second one. Same scale dimension here. Make sure that my units cancel each other out. Multiply them straight across. Once I get the improper fractions here, I need to turn them into mixed numbers. So take the top divided by bottom, and that's how I get my 2. What's left over is a fraction. I might have to reduce it one more, but in this case, I'm good with 2 1/4. Okay, so I don't leave my measurements like this. I put it in the official way, so I have width by length here for my room measurement. Okay, number 9 in section B says to find the size in acres or hectares to the nearest hundredth of each rectangular lot. So we need to now work with our land. And so here in my example, I have 135 foot by 169.2 feet, it says. And so what do I need to do? I first need to find the area. So I'm going to go ahead and multiply them together to get the area. And then I need to go ahead and use my scale. Now remember, it said that my, for square feet, there are 43,560 square feet in an acre. So I'm going to take my area that I just found and divide it by my scale factor. Another way to do it, looking like what we've been doing with dimensional analysis, would look like this. 22,842 feet squared times my fraction here, which is, I've got my 43,560 feet squared with 1 acre. Ran out of room here. Those cancel each other out. And now I just multiply it, and then I divide, and that's how I got the 0.52 acres. Okay, so 10, 11, and 12 are exactly the same thing. You're going to have to use your conversion factors that the book gave you, so watch what they're asking for. Okay, 13 through 16 is dealing with our roof scale. Okay, so we need to go ahead and find and convert our scale of our roof. They gave us, it is 14.5 inch by 20 inches. So I need to take the width, convert it out. And so my inches now cancel each other out. I don't want that as a fraction. So remember how I multiply by the reciprocal. Okay, those cancel out. So I end up with, I quickly show this to you here, 14.5 times my 4. And that's how I got the 58 feet. Doing the same here, I need to cancel it out by 4 over 1 times 4 over 1. And so I end up, those cancel out, giving me 1. My inches have already canceled each other out. So simply, what is 20 times 4? That's 80. So those are my measurements now. Now I need to take and convert and adjust my width because of the pitch. And in the instructions, it says my pitch is 4 to 12. So I need to go back to the chart on page 392, and it says 4 to 12 is 1.0541. So I'm going to take that factor, multiply it by the width that was up here, and that is the new width I'm going to use. Okay, now remember in our example in our book, what is the next thing I need to do? I'm going to find the area. Use this new number for my width and multiply it by my length over here. Okay. That gives me my area, is what I'm looking for. Okay, if you flip over your book to page 394, you have a real life example here going for you. 17 through 22. It gives you a dimension of a single story house. You're going to apply everything that we did here to this problem. And good luck on it. Have a good day, and we'll see you when school gets back in session. Bye.